Hello, my name is Edwin Robbins, and I'm a senior sales engineer with Denodo. Today, I'm going to provide a brief overview of Denodo 8's data virtualization capabilities. I'm going to begin with a brief overview of Denodo's architecture, and then I'll do a demo of Denodo's latest product release, Denodo 8. During the demonstration, I will cover how to create a new data view in Denodo from multiple disparate data sources, how Denodo optimizes query performance, and finally, how end users can access Denodo and leverage Denodo views in their reports and applications. Enterprise data virtualization provides applications real-time access to disparate data sources. If we look at the bottom of this diagram, we see many of the most common data sources that companies are using today. Everything from traditional relational databases to SaaS applications, Hadoop, and web services. The top of the diagram represents the different types of data consumers that corporate IT services. In the middle, we have Denodo's data virtualization server, which provides the connectivity for any application to access the data from any data source. As you will see in the demo, Denodo provides a data abstraction layer for the BI and application developer so that there is now one place for them to connect to all their data assets. For the demo today, we're going to look at a classic use case that really highlights the difference between data virtualization and classic data integration approaches. In our example, the marketing team has recently run a marketing campaign, and they want to understand the impact it has had on sales in various countries compared to past campaigns. From an IT standpoint, this presents some challenges. In this case, the campaign management application is a SaaS-based app running in a private cloud, so there is no database level access. Our only way of extracting data is to call a web service that returns a JSON document with the campaign information. We will also need to access our historical sales information to see how the current campaigns have done versus prior years. And in this case, we have offloaded all our sales history data to a Presto cluster. Lastly, we will need data from our on-premise CRM system, which is running on an Oracle database. Even though this is a relatively simple request from an analytics standpoint, it requires us integrating data from 3 different types of data sources, all with their own formatting issues. With traditional data integration tools, we would typically solve this problem in one of 2 ways. We could either create an ETL job that extracted all the data we might need from each of these data sources and then store that data in a separate data store so we can query it, or we could have a power user that knows each of the data sources, extract from each of them the data sets they need into a desktop tool like Excel, and manually combine the data. Both of these approaches have some obvious drawbacks. Creating a new ETL job and moving the data to another location for a simple query like this is not practical from a resource standpoint and would probably take too long to be worthwhile. On the other hand, letting a user extract the data to Excel makes it difficult to enforce enterprise governance standards. Data virtualization provides a different approach to solving many data integration problems. Our goal is to provide users and applications seamless access to any data asset in your organization while making it easier to maintain your corporate governance. In this scenario, Denodo would first establish a physical connection to each of the underlying data sources. In the case of our campaign management application, which is a SaaS-based and running in a private cloud, we would be making a REST API call. In the case of Presto and Oracle, we would be making a JDBC connection to each one of those servers. Once we've established connectivity to each data source, we then identify the physical object in each source that we need for our analysis. In the case of Presto and Oracle, those objects will be database tables. In the case of the campaign management application, it will be a JSON document. We then import the metadata for each of those objects. We only require the metadata from each source because Denodo does not persist data from your source systems. Once we've imported the metadata for these objects, they are represented in Denodo as what is called a base view. Denodo has 2 types of views, base views and derived views. Derived views are created in Denodo from other views. On this slide, you can see the base views represented by these grayed out boxes. A base view in Denodo is a one-to-one metadata mapping back to a physical object such as a database table. Once we've imported the metadata for our base views, the the Denodo developer can begin the process of combining and transforming those base views into a new derived view to be used by our business analyst. At runtime, the end user will connect to Denodo using Tableau or any BI tool of their choice and query the new derived view that we have created. Depending on the query that is issued to Denodo, it will then determine what the optimal execution plan is for retrieving that data from the original sources in real time. Rather than extracting and storing the data somewhere for later use, we're providing real-time access to the data where it resides. Now, let's take a minute and see a demonstration of Denodo's data virtualization. In Denodo 8, we implemented a single sign-on solution for all of our tools, and this is the initial sign-in page. I'm first going to log in as a Denodo administrator and show you how we create Denodo-derived views to be consumed by our end users. This initial page shows me the environments and Denodo tools that I have access to. We have two environments configured, a Denodo development environment and user environment. As the Denodo administrator, I have access to both environments. And as we will see later in the demonstration, different users will have access to different environments and tools. We also have several links on the right-hand side of the screen so that users can quickly locate whatever training or documentation they may need. I'm now going to launch the Design Studio and walk through the process of creating a new Denodo-derived view to be used by our BI team. In version 8 of Denodo, we released a new web-based Design Studio for the Denodo developers and administrators. The Design Studio is similar in layout to many database development tools like Toad and SQL Developer. On the left-hand side, we have a list of Denodo databases. Since these are only storing metadata, we refer to these as virtual databases or VDBs. Today, we will be looking at the VDP type named Integrated Demo. Inside the integrated demo, we see they have different layers. The first one we're going to look at here is the connectivity layer. And I'm going to expand the connectivity layer and the data sources to show we have a folder for Oracle data sources and SQL Server. And I just want to take a closer look at the CRM data source, which we're going to be using in our query today. So you'll see that the CRM data source is really just using a simple JDBC connection back to our Oracle database. So since this connection has already been defined for me, if I wanted to import any tables from this CRM as a base view, I simply click on Create Base View, navigate the schema that holds the table that I want, and in this case, I'm going to select the customer table. So I go ahead and say Create Selected, and Denodo has now created a new base view called Customer, which is mapped back to the customer table in my CRM database. Okay, so once you've imported all the base views, we have organized them here in this base view folder. And typically after you've imported all of your base views, you're going to want to do some cleanup. Where is it? We probably want to do things like apply some data quality checks and standardize the naming conventions before we make them available to the rest of the organization. Once that step is complete, we can then create a common set of views that our developers can use as building blocks to create their own more customized views and queries. The integration layer is where we have organized these various common building blocks. And today we're going to look at a couple of those common building blocks in the dimensions and fact tables folders. So we're going to start building our marketing view by selecting the store sales history fact table, and I'm going to create a new join. So this creates the join palette, and then I'm just going to go ahead and drag on the dimension tables that I want to join to that fact table. And this is going to simply be a drag and drop operation, and then identifying which columns to find the join. So that's my campaign management. I'm now going to join up my customer table with my store sales. And then lastly, I'm going to bring my date dimension and tie that to my fact table as well. Okay, so once I've defined my joins, since this is going to be an aggregate query, I'm going to need to define my group by as well. So for my group by, I simply need to select the columns that are going to make up the group by clause. So that's going to be promo name, birth country, and month of year. Okay, so those three columns are going to define my group by clause. And then the output tab is where the end user is going to see of the view. So we're going to give the view a new name, and we're going to call it campaign evolution by country. And then I'm going to clean up each of the individual field names so that they're a little bit more readable for my users. So I'm going to call that one month, call this one country, promotion. And then the last thing I need to do is I need to add a new calculation for my total revenue by campaign. So I'm going to click on new and say I want to create a new aggregate field, and I'm going to call this total. And I'm just going to start typing in the function that I want to use, which in this case is sum, and the column that I'm going to use. And then I'm going to just hit autocorrect when I got a few of the characters typed, and it fills in the autocomplete for me. So that is my total calculation. I have my view, so I am all set in creating my new view, and I'm going to go ahead and save it. Now, before I go ahead and run it and test it, I do want to just real quick go back over to the PowerPoint and touch on Denodo's execution and how it's going to work. So as I mentioned earlier, when consuming applications query Denodo, the cost-based optimizer determines in real time the most optimal means to retrieve the data from the source systems. So how is the optimizer determining those execution plans? The most important input is the incoming SQL statement itself. If the query has query predicates or is using some type of aggregate function, then Denodo is going to try and push that functionality down to the source system. The metadata on the source tables involved in the query is another input for the optimizer. Things like primary key, foreign key relationships. Does a given column have an index on it, or is it used as a partition key? Also, things like data statistics at the table are used in the query will be used to estimate the data volumes of the query. And finally, what are the source capabilities of the underlying systems? Is the data source a flat file, or is it a table in an RDBMS? Is it a database? If it is a database, can we create temporary tables to speed up the query, or is it a read-only connection? If the database is an MPP, what is the size of the cluster? The Denodo optimizer is going to incorporate all of that data into its algorithm and assign a cost to each potential execution plan and choose the plan with the lowest cost. So let's take a look at a simple example of how the optimizer can greatly enhance performance. Here we have a fairly simple query requesting the average sale amount for each of the 50 states. Now, while this is quite a simple query from a business standpoint, it represents a challenge because the sales and customer data are in different sources. So what's the best execution plan for a query like this where our data sets are in different places? These diagrams represent three potential execution plans that the Denodo optimizer can choose from. Option one is what we call the naive strategy. This is the method used by most federated tools. The approach is to issue a select star from sales and a select star from customer, have all the data returned to the server, and then join and aggregate the data. The problem with this approach, and the reason why most people end up frustrated with federated query tools, is that we are moving way too much data over the network. Before we can even start calculating the result, we need to move 300 million rows from the sales database. Because the Denodo optimizer is factoring in all of the available metadata, it will ignore the naive strategy and choose either option 2 or option 3. Option 2 represents an execution plan leveraging temporary data movement. This plan will copy the 2 million rows of the customer table into the sales database and have the sales database execute the join and group by in place. In this scenario, Denodo is acting more as a query coordinator than a query processing engine. Option 3 represents an execution plan leveraging partial aggregation pushdown. In this case, Denodo sees that customer ID is the primary key in the customer table, and it also sees the column used to join the sales table to the customer table. So to minimize the amount of data we must move over the network, we can first aggregate the sales data at the customer ID level. That reduces the rows returned from the sales database to 2 million rather than 300 million. Then the 2 million rows from the customer database are joined with the 2 million rows from the sales database. And then finally, a second aggregation is done at the state level inside the Denodo server. Now we're going to switch back over to Denodo to show how the cost-based optimizer affects the view we created. The query that we created in the previous step is using the store sales historical fact table, which has about 2.8 million rows in it. So before I go ahead and actually run or test a query using this view, I'm going to want to make sure that Denodo is going to execute the query the way I expect it to. So I'm going to click on the query plan button, which is part of our execution panel, and see what Denodo's plan is for executing this query. So here we have the execution trace, which has a graphical component, which you see over here on the left-hand side, and also a textual component you'll see over here. Okay, so if I click on the very top level box for execution plan, the first thing I always look for is what are the optimizations that Denodo plans on applying. And it says here that it's going to apply join reordering, and most importantly, it's going to apply aggregation pushdown, which is what I'm expecting it to do. So since I see that the plan is going to execute the query that I want, I'm now going to go ahead and execute it. And when the results come back now, I'm going to check the execution trace again to see exactly how the query executed and what went on. So now if I click on the very top box, you can see I have a lot more information available to me. I see that it did in fact execute the optimizations it planned on. I can see the time that it spent doing the optimization. I can see the total rows returned and the total execution time. I can also see each of the individual components of the underlying queries itself. So this query is actually made up of 3 separate gets to our different data sources. So if I take a look over here, I can see that this is making a connection to a web service, and this is actually returning about 300 rows that are coming back in our JSON document. This is our connection to our Oracle database, and I can see that this is returning about 96,000 rows from the customer database. And then lastly, we have our connection to our data lake. Now, remember, I mentioned that the Presto table had about 2.8 million rows in it. Well, if you see here, we're only returning a little under 1,700 rows from the Presto server. And the reason for that is because here is where we're applying that aggregation pushdown. So you can see if I look at the query that's being passed down to Presto, we have several sum functions embedded in that query. And so rather than executing the entire aggregation inside Denodo, we're basically pushing that aggregation down to Presto and just returning the result set to Denodo. Now that we've tested the query and validated that the optimizer has chosen a good plan, it's time to make our view available to the BI developers who requested it. To do that, we're going to go back to our single sign-on page and connect to the data catalog. The Denodo catalog provides a single point of access for all the assets managed by Denodo. This is typically the place that the BI and application developers will go to find Denodo views to use in their applications and dashboards. All of the view metadata is indexed in the repository, so you can search by a view name, column name, or description. The initial screen we come to is the View Summary tab, which displays all of the metadata for the given view. You can see that we've already have descriptions for 3 of the columns, but not the 4th, and we also don't have a description for the view itself. While the data catalog is mostly a read-only interface, we do have the ability to update and augment the view metadata. So if I go ahead and click Edit, I can create a new description for the view summary. So this is a marketing view used for campaign analysis. And I'm also going to update the total. This is total revenue per campaign. And then we also have the ability to add additional metadata tags. So here we can add either and or a category and a tag to Denodo. So I'm going to put this in the marketing category, and I'm going to apply the certified tag, which means that I validated that this view can be used in reports and that it contains valid enterprise data. So now that I've updated the metadata for this view, as the administrator, I'm done, and I'm going to turn it over to the BI developers. So I'm going to go over to my other launch page, and now I'm going to connect as one of the BI developers, W. Brady. And now that you see that I'm logged in as one of the Denodo end users, you can see I have a much more limited set of tools available to me. I also only have access to the Denodo end user environment, since I will not be creating new Denodo views for myself. I'm going to go ahead and launch the data catalog. And I could go ahead and do a metadata search for the view directly here, like the administrator did. But the development team told me that they put the view under the marketing category so that it would be easy to find. So I'm going to go ahead and look under marketing category. And there it is, campaign management by country. So I click on the initial view summary page. I can see that all of the metadata looks accurate. The description of the view looks like it has what I'm looking for. But before I do anything else, I'm going to check the lineage. So the lineage is going to give me all of the data sources and views that are used in this to create this derived view. It's also going to tell me what the joins were. And it's also going to show me the actual navigation path for any of the individual columns. So if I click on month, it shows me that month is coming from the EDW, and all of these are interactive, so I can see the definition of that EDW. I can even see that the campaign management data source is completely different because that is a web service. Even if I click on one of the calculated fields like total, it's going to show me the lineage of the column that's used in the calculation, and it's also going to show me the calculation itself right in the lineage. So once I validated that all the data is coming from the correct sources, the calculation looks correct, all of the navigation paths look correct, my last step is to actually sample the data. So if I click on the query tab, I can go ahead and run a quick sample query from here just to validate that it's going to bring back correct results. And everything so far looks correct. And so my final step would be to connect to this view using the BI tool of my choice. So if I click on this little plug here, this will give me all of the connect string information for any of the various APIs that I can use to connect to Denodo. So if I wanted to use a JDBC tool, I could just copy this, same with ODBC. But if I wanted to use Tableau, we actually have integration built directly into the data catalog with my Tableau desktop tool. So if I click that button, it's going to create a connect file that is going to launch my Tableau desktop and is going to automatically connect me to the view that I was just looking at. And there it is. So I can go ahead now and build my report in Tableau directly off of that view that I just found in the data catalog. And that concludes the demonstration and presentation for today. I would like to thank everyone for taking the time to follow along. And if you have any questions, please reach out and ask.